In this last video, what we want to look at is what does the graph of a logarithmic function look like? Well, if you remember from the first video, we said that logs are the inverse function of exponentials. So we can use this to help us graph them. So for example, if we want to graph y equals log base 2 of x, we can use the fact that this is the inverse of y equals 2 to the x, right? They are inverse functions of each other. So that means if we can make a table of values for y equals 2 to the x, we can also make a table of values for log base 2 of x. So we'll just pick some nice, easy to use numbers, -2, -1, 0, 1, and 2. And we'll either use our calculator or use our knowledge of exponents to fill in this table. We'll get that this is 0.25 or 1/4. This is 1/2 or 0.5. This is 1, this is 2, and this is 4. So we can go ahead and we can graph that really quickly. -1, 0.5, 0, 1, 1, 2, and 2, 4. And we can then use that to kind of fill in. We know that these end up having to be these nice smooth swoops. Remember that approach the x-axis but never touch them. Well, now that we have that table of values, we can use that to help us fill in the table of values for the log. Because we know these are inverse functions, that just means that we have to swap x and y. So for our log table of values, we can put when x is 0.25, y must be -2, and so on, right? 0.5 and -1, 1 and 0, 2 and 1, 4 and 2. And then we can use that to graph. So x is 0.25, we have -2. X is 0.5, we get -1. X is 1, we get 0. X is 2, we get 1. And x is 4, we get 2. And now you can probably kind of see where this is going if you fill in a nice smooth swoop for this as well. Now you can notice that just like our exponential function slowly approaches the x-axis but never touches it, our logarithmic functions are never going to touch the y-axis, but they will slowly approach it. And you can also notice, like we know should happen for all inverse functions, these are reflections of each other across the line y equals x.